Good morning, students. I am Dr. V.P. Anuja, Associate Professor of Mathematics, Arulmigu Palaniyandavar Arts College for Women, Chinnakalaimuthu, Palani. Before moving into the topic, let us recall the definition of transportation problem. The transportation problem is a special type of linear programming problem, where the objective is to minimize the cost of distributing a product from a number of sources to a number of destinations. Transportation deals with their transportation of a commodity from M sources to N destinations. There are three methods to find initial basic feasible solution. They are northwest corner method, least cost method, Vogels approximation method. Here we are going to see an example for Vogels approximation method. Look at here. There are three sources O1, O2, O3 and four destinations D1, D2, D3, D4. The available sources are 300, 400, 500 in O1, O2, O3 respectively. The destination requirements are 250, 350, 400 and 200 in D1, D2, D3 and D4 respectively. Here, the total demand and the total supply are equal. The value is 1200. So, the given problem is balanced transportation problem. Whenever the differences in the row or column are calculated in each step, the differences between the least and the next to least cost in each row and each column are calculated in the respective rows and columns. Look at here. In the first column, the least cost is 1 and the next least cost element is 3. So, the difference is 2. In the second row, the least cost is 2 and the next least cost is 5. The difference is 3. In the third row, the least cost element is 2 and the next least cost is 3. The difference is 1. Here the 2, 3, 1 are the row differences. Next we have to find the column differences. In the first column, the least cost element is 2 and the next least cost element is 3. So the difference is 1. In our second column, the least cost element is 1, next least cost element is 3. The difference is 2. In the third column, the least cost element is 3 and the next least cost is 5. The difference is 2. In the fourth column, the least cost element is 2 and the next least cost is 4. So the difference is 2. Here 1, 2, 2, 2 are the column differences. Next, we have to find the largest difference. The largest difference is 3, which corresponds to the second row. The minimum cost in the second row is 2. It is in the first column. Hence, the first allocation is made in the cell 2, 1 to the variable x21. x21 is equal to minimum of a2, b1. Here the a2 value is 400, b1 is 250. So the minimum element is 250. 250 is in the first column. So we cross the first column. Next, from the remaining cells, we have to find the row difference and column difference. Here, we delete the first column. So, we cannot find the column difference. So, we put the dash here. Next, in the second column, the minimum element is 1. Next least cost is 3. So, the difference is 2. In the third column, the difference is 2. Fourth column, the difference is 2. First row, the difference is 1 and 4 is 3 and 5 and 6 is 1, 2 and 3 is 1. The largest of these is 3. It is in the first row. The minimum element in the first row is 1. It is in the second column. So, we find the value of x12. Minimum of A1, B2, 300, 350. The minimum element is 300. So, we cross off the first row. The minimum element is in A1. So, we cross off the first row and subtract 300 from 350. The remaining is 50. Next, to find the row difference and column difference from the remaining cells. Here the column difference is 3, 3 and 6 is 3, 3 and 5 is 2, the column difference 2 and 9 is 7. Here first row is crossed. So the second row difference is 1, third row difference is 1. We find the largest of these difference is 7. Which corresponds to the fourth column. Okay, in the fourth column, the least element is in the third row. It is 2. So, we find the value of x34. x34 is equal to minimum of A3, B4, 500, 200. The minimum element is 200. So, we cross off the fourth column. Subtract 200 from 500. The remaining element is 300. Next, find the row difference and column difference from the remaining cells. The row difference is 1, 0. Column difference is 3, 2. Find the largest of these differences. The largest difference is 3. The minimum cost value is in the cell 3, 2. We find the value of x32. x32 is equal to minimum of 300, 50 is equal to 50. We cross the cell second column. We cross the second column. Subtract 50 from 300. The remaining value is 250. Next, to find the row difference and column difference. The row difference is 5, 3. Column difference is only 2. The maximum difference is 5. Okay, we find the value of x23 is equal to minimum of 150, 400. The minimum value is in 150. So, we cross off the second row. Next, the last value, the only one value is 3. It is in the third row, third column. X33 is equal to 250, 250. So, the value is 350. And initial basic feasible solutions are x12 is equal to 300, x21 is equal to 250, x23 is equal to 150, x32 is equal to 50, x33 is equal to 250, x34 is equal to 200. Total transportation cost is equal to 300 into 1 plus 250 into 2 plus 50 into 3 plus 250 into 3 plus 200 into 2 plus 150 into 5 is equal to 2850. Okay, we will see another example in our next class. Thank you.